Okay, just let me share my screen here. Okay, hopefully you can see my Lasair homepage. So yeah, I'm just going to describe here a few ways that you can tickle the Lasair API, the REST API. So we provide a bunch of interfaces onto Lasair, including, of course, Kafka. And you can create your own Kafka stream. You can turn your streaming query into a Kafka stream and query that later on. But I'm just going to show you just very simply here how we can interact with Lasair via the API. So I've just created a few notebooks here which I concatenated together. My colleague Roy has very kindly written a piece of software called Lasair. So if you do pip install Lasair, then that will run what you need to. That will give you a small helper function. This helper function is completely optional. You do not need to use it. You can call it, obviously, if your client code can talk to the system via JSON and REST API, then it can be any system. So let's before we even start, in fact, can I encourage you to go to the Lasair pages and sign up and grab yourself a username and password. And then what I've done here is I just created a little get token script. So here's how to get your API token. So you just call the Lasair thing, the API via curl in this case. Let's just do that. And what you should do is get a response like this, which is a token which I've created, which by the way will expire on Friday, including that username and password, which I just showed you. So don't worry about it, but it's quite a powerful user ID. So this can do about 10,000 requests per hour if necessary. So in here, I just want to show you, of course, everyone, all of the brokers are offering a cone searching ability. So we are no different. First of all, of course, let's just use the small helper code from the Python PyPy repository. So hello. So this is a Google Colab setup. So this is where this notebook is running. So it's not co-located with our current infrastructure at the moment, which means superpower queries will need to be done via our Jupyter Hub, but our Jupyter Hub is in flux at the moment, so I'm not going to show you that yet. Do what I've just done, which is go and grab my token. Surprise, surprise, it's exactly the same token. And then import the Lasair client and the Lasair code from Lasair. And all I want to do now is just grab, let's just give me the objects within 16 arc minutes of a particular location, which happens to be a particular nice supernova. So just give me all the objects that happen to lie in that footprint, which is a 16.6 arc second radius, arc min radius, sorry, I should say. That's currently our maximum, but if you want to do cone searching in bulk like this, I would highly recommend that you create watch lists, which we've described before in previous talks, but happy to go through that with you again. So let's just do that. Let's just grab, so I'm actually doing this all together. So I'm doing 3 different things. Give me the number of objects within that search radius, give me all of the objects within that search radius, or give me the nearest object within that search radius. Oh yeah, so that's nearest. So let's do that. Let's run all 3 of them. Is that running? Okay, there you go. So it just prints out there's 11 objects. The nearest one is 0.01 arc seconds away, and then here are the rest of them in ascending distance of closeness to the particular RA index I chose. So just as an option, now that we've got this data, we can go and grab the light curves. So there's 2 ways to do this. There's an object there's an objects API, and there's also a light curves API. What did I do here? I can't remember. So here's the list of objects. And I think it's the list of light curves. Yes, objects, sorry, objects is the one I'm calling, sorry. So let's do that now. Okay. So it's just gone off and collected those and then just plots the light curves for the relevant objects. So that one that the objects are centered around is this particularly nice supernova that was discovered 26 days ago. So then the next part of it I was just going to describe is our streams setup. So you can, like I said, you can create your own stream. You can give that stream topic ID, and then you can query it either by Kafka or you can actually query it by the API. And in fact, give me all the streams that are currently available on the system at the moment. So let's do that now. Of course, it's the usual grab my API token, got my token, grab all the available streams. So give it a regular expression and say, just go and collect them all. And it should go back and say, here are all the current streams available on our broker. So let's just go and collect what's currently on the two sea snails stream. So it just goes and collects all in fact, I collected the latest object, or sorry, an object from the sea snails stream using this setup. And finally, I just wanted to describe our context classifier. So we've exposed our context classifier via REST API. So you can give it a bunch of ZTF objects, and it will tell you what it thinks the object may be, bearing in mind that these are from difference image detections normally. Or you can give it a random array in DEC and say, well, what is the object at that position, if there's an object at that position. So same as usual, go and grab my token. There's my token. Go and grab a bunch of objects. So I'm going to go and grab a bunch of objects from the supernova light candidates topic. So hopefully that completed. And I'm just going to grab the short info for those topics. I'm just going to present it in JSON here. So it's off to do that. Shouldn't take that long. Come on, here we go. So so it gives you a bunch of different objects, and where is it? Yeah, so a bunch of summary data and a bunch of context data for these objects. I'll just go right up to the top. Sorry, this is a large. There we go. So, so it thinks that these are either supernova or nuclear transient or AGN or unclear or variable star, depending on the kind of object that it happens to have submitted. And then finally, let's just go and grab, we know that ZTF isn't in the southern hemisphere, so let's go and grab a crux, alpha crux, which we know is at -63, so let's go and grab that from Sherlock, and it tells me this is actually the GuiStar catalog designation of that particular object, and it's a 1.2 mag object. So I just wanted to give you a quick flavor of what's available. So we have basically two Lasair brokers running at the moment. We have our old Lasair and new Lasair broker currently running, and the new Lasair broker will eventually become the de facto Lasair broker. Okay, that's it from me.
Thank you very much. Are there any questions? Okay, then I thank you very much again, and let's go to the next.